Hi everyone, this is part 3 of my naming videos, and this is going to focus on polyatomic ions. So this is going to be anytime you have a polyatomic ion in the compound, whether it's type 1 or type 2, I'll cover in this video. So make sure you have your polyatomic ions list. If you're in Chem 1-2, it's likely you don't have to memorize these. If you're in Chem 3, it's likely you have to memorize these. So your list might look like mine, it might look something different, but these show some of the most common polyatomic ions. So first of all, what are polyatomic ions? Well, they're groups of ions that are technically covalently bonded together, but they act as a team and they are ions. So for example, one of the most common ones is nitrate, NO3 with a charge of minus. It's 1 nitrogen and 3 oxygens that are bound together and they stick together as a team. And collectively, the four atoms, NO3, they act as an ion. So they'll bond to other cations, so they'll bond to cations and they'll act as a -1 charge or 1 minus charge. So there's a whole list of these. You got to be careful with some of the names. The vast majority of polyatomic ions are anions, negative. There's one polyatomic cation listed here. There's another one you'll learn later in the year called hydronium, which is H3O+, has to do with acids. But most polyatomic ions are anions. You could see almost all of ours are. Be careful with certain spellings, like for example, nitrate and nitrite. Very similar in spelling, but very different. The difference is from 8 to 8, you drop one O but keep the same charge. Same with phosphate, phosphite, sulfate, sulfite. You even see it down here with hypochlorite and chlorite, then chlorate and perchlorate. So the ite and the 8 have a different number. You might wonder why some of these are in bold. A few years ago, we used to require Chem 2s to memorize these, and these were the ones we had them memorize. Now, it's possible that might come back, but at the time I'm recording this video, we don't require Chem 2s to memorize it. If you're watching this in a future year and I changed my mind and made you memorize that, sorry, there's probably a good reason for it. But anyway, that's why these are bold. It really doesn't mean anything. It also, well, I guess they'll tend to show up more on worksheets that we make because these are the ones that we use to hold people accountable to. But you should also be familiar with these down here. These are, for example, perchlorate forms perchloric acid, which is a very common acid. What else to know about these? Oh, acetate, acetate. See what's listed twice? These are two alternate ways of writing it. I would say the top one's a little bit more common, but sometimes acetate's written out as C2H3OO-. You might say, why would you ever write it out as OO? Why wouldn't you make it O2? Well, in the acetate ion, I almost said molecule, in the acetate ion, the fact that the two O's are directly bonded to each other is a distinct feature of the acetate. It's important that acetate be shown with the OO. Well, it doesn't have to be, but in some cases it's shown with the OO just to drive that point home. Either way is totally acceptable. I tend to default to go with the top way of saying it, but either one is fine. Yeah, let's move on with this. So when you're making a compound with a polyatomic ion, you again just treat it as a team. So let's say we're going to have calcium bond with sulfate. Calcium bond with sulfate. Well, calcium is 2+. Sulfate, according to your sheet, SO4, 2-. Notice the ratio. 2+, 2-, comes together, and it's simple as that. CaSO4. When you name this, you have to think, is it type 1 or type 2? Well, calcium is a type 1 metal. If you don't know what I'm talking about, review one of the previous videos. We know calcium is always 2+, so you just say calcium. And for this, you actually don't change it at all. You don't change it to "ide" or anything. You just say the name of the polyatomic ion. So this is calcium sulfate. That's it, calcium sulfate. Let's pretend we have iron with a 3+ charge bonding with phosphate, which is PO4, 3-. Again, I picked an example where the 3+ and the 3- are balanced. So if you want, you can even crisscross them, but then simplify it down. But this is just going to end up being FePO4. Now, because this is a type 2 metal, and if you don't know what I'm talking about, review the previous video, iron is a type 2 metal, you can't just say iron phosphate, because the phrase iron phosphate could refer to a whole variety of different combinations depending on the charge of the iron. So you have to find out what the charge of this iron is, which is given right there, and that becomes the name. So this one is going to be iron 3 phosphate. Okay? So notice, it's actually pretty easy to name these. You just state the polyatomic ion as your anion, and then the first part's just going to be the name of the metal if it's type 1, or the name of the metal plus the charge if it's type 2. Now obviously these get more complicated when it's not 1-to-1 ratios. For example, what if we have zinc bonding with hydroxide? Hydroxide is OH minus. Well, zinc is, first of all, ask yourself, is zinc type 1 or type 2? Even though it's in the middle of the transition metals, it's a type 1 because it always has a 2+ charge as part of that 3-2-1 rule. So when these bond, notice the 2 is going to go with the hydroxide and the minus is going to go with the zinc, or I should say the 1. And really, if you think about it like this, imagine you have zinc and you have hydroxide and you need to balance it out. How many of each of these are you going to need? Well, obviously we're going to need 2 of these -1s to balance out the 1, 2+. Now, if you just crisscrossed it and wrote it like this, Zn1OH2, notice the problem. It doesn't correctly show that you have 2 hydroxides. The way this is written, you have 1 zinc, 1 oxygen, and 2 hydrogens. That is not correct. Really, you have 1 zinc and 2 hydroxides. So the way we show this is using parentheses. You put the hydroxide in parentheses, or if I want to clean this up a little, it's Zn parentheses OH close parentheses 2. That is a proper way to write it. And you might say, you know, come on, is it really necessary? Can't you just write it this way? No, because this shows 1 O and 2 H's, so this is not correct. This is how you would do it, and this would be called zinc hydroxide. Another example. Let's say you have iron with a 3+ charge bonding with sulfate. Yeah, let's do sulfite, SO3 2-. Okay. Again, if you didn't use parentheses and you just put the 2 there and the 3 there, here's what it would look like: Fe2SO3 3. And here you can really see the problem because it now looks like you have 33 oxygens on there. So you have to use parentheses. So it's going to be Fe2, and then to show that you have 3 sulfites, you put parentheses SO3 close parentheses 3, and that's how it's done. Now when it comes to naming this, you can't say iron sulfite because iron's a type 2 metal. You have to look at the charge, realize it's 3+, and call that iron 3 sulfite. Okay? So to reiterate an important point here, when do I use parentheses? When do I not? You don't always use parentheses with polyatomic ions. The answer to this question is you use parentheses when you have more than one of those polyatomic ions in the compound. Notice, for our first 2 examples, you had 1 calcium ion and 1 sulfate ion, no parentheses. Here, you have 1 iron ion, 1 phosphate ion, no parentheses. You do not use parentheses when you only have 1 of them. In fact, you are wrong if you write this. Okay? And when it comes to naming, there are very clear right and wrongs. And don't blame me, blame the IUPAC in France, like I always say. So this is not the right way to write calcium sulfate. Because there's only 1 polyatomic ion, you don't use parentheses, you write it as CaSO4. Same thing here, you don't say FePO4 in parentheses, you just say FePO4. When you have more than 1 of them, meaning here you have 2 hydroxides, you have to use parentheses. Here, when you have 3 sulfites, you have to use parentheses. So parentheses have to be used when you have more than 1 of the polyatomic ion, and they cannot be used when you have only 1 of the polyatomic ion. That's the rule. Let's go through some examples. So in terms of naming, really the big question to ask yourself, first you have to identify the polyatomic ion, which is as simple as looking at your sheet. And then you really just ask yourself, type 1 or type 2? Barium, type 1 or type 2? It's type 1, it's in group 2A. So naming this is going to be very simple. barium nitrate. Barium nitrate, that's it. You don't say barium dinitrate or anything like that. You just say barium nitrate. NH4I. Now, normally with ionic, we're looking for metal bonded to nonmetal. This is a rare case where there's actually not a single metal, but you gotta be aware enough to notice the NH4 when you see it there. Okay? NH4 is ammonium. It's the polyatomic cation. This is not going to be covalent. Normally, nonmetals all bonded together are covalent. This is not one of those examples. So NH4 is ammonium bonded to iodine. So here's the question. Is ammonium a type 1 cation or a type 2? And what I really mean by that is, do we always know ammonium's charge, or does ammonium charge fluctuate? Ammonium is always +1, so therefore it's type 1. So no Roman numerals. You simply say ammonium iodide. Next one, cobalt is CO. You got to recognize this as acetate. It's one of the ones near the top. So question you ask yourself, is cobalt type 1 or type 2? Well, cobalt is type 2. It's a transition metal, which could have variable charges. So this cobalt is, one of these cobalts are bonded to one of these acetates. So I can figure out easily the charge of that cobalt. This cobalt must have a +1 charge. Let me run through that again. Acetate has a known charge of -. And by the way, careful. Notice here it says C2H3O2-. Acetate does not have a charge of 2-. The 2 is a subscript that goes with the oxygen. The charge is technically a superscript. It's not shown well here, but it's a 2 up, like this. C2H3O2-. This entire thing has a charge of -, not 2-. If it had a charge of 2-, it would look like this. Okay, so we have one cobalt bonded to one acetate. Acetate is -1. Cobalt must be +1, which gives us cobalt 1 acetate. And no, you do not leave out the 1 if it's a 1. A lot of times we don't write 1s, but this time you have to write the 1 there. Last one, Ag2SO3. So Ag is silver. That's part of our 3-2-1 rule. Silver is a type 1 metal, even though it's smack dab in the middle of transition metals. So we have to figure out, we don't have to figure out the charge. This is simply going to be silver sulfite. So when it's type 1, it's literally as simple as saying 1, 2, silver sulfite, barium nitrate. When it's type 2, you got to follow those rules. Cobalt 1 acetate, and this one is type 1 as well. All right, I'll go a little faster with these examples. So rubidium, if you want to pause here, maybe work through these and then unpause. Rubidium's type 1, so all we're doing is just naming it. Rubidium carbonate, that's it. Rubidium carbonate. Next one, manganese, Mn, not to be confused with magnesium. Manganese is a type 2 metal. It's a transition metal. Now notice this one, there's a lot of numbers going on here. I'm going to take my time with this. I'm going to maybe write out my grid that I did in the last video. So we need to figure out the charge on this manganese in order to name it. Well, there are 2 manganeses. So I'm going to write Mn, Mn. That's what's on the positive side. On the negative side, I have 3 sulfites. Okay, we need to figure out the charge of this manganese. I don't know manganese's charge, and looking at the periodic table is not going to help me. But what I can look at is my polyatomic ions list, and notice that sulfite always has a 2- charge. So what must that manganese's charge be in order to balance this out? What must each of these be? Well, each of these must be 3+. That's the only way to balance it out, and therefore this is going to be manganese, Roman numeral 3, sulfite. And just to clarify, it is not 3 because you have 3 of these on here. It is 3 because the charge of the manganese is 3+. Okay. Next one, NH4 3P. You got to recognize NH4 when you see it. Really, anytime you see parentheses, you know it's going to be an ionic compound, a polyatomic ionic compound. So NH4 ammonium is a type 1 compound, a type 1 ionic. You don't need to clarify the charge. It's simply going to be ammonium phosphide. Careful, not phosphate, not phosphite, phosphide. Last one, very simple, NaOH. You got to recognize OH as hydroxide. Na is a type 1 metal, sodium hydroxide. Very common compound there, sodium hydroxide. Okay, and now to go the other way, writing formulas. So, as I said in the last two videos, I'll say it again. When you're writing formulas of ionic compounds, write the ions out first with the charges, then write the answer. Don't try to do it all in one step. Calcium acetate. Let's write the ions. Calcium is Ca2+. Acetate, you check your sheet, C2H3O2 minus. Now the charge is minus, the charge is not 2 minus. So now all you do is crisscross these and write the correct formula. So we have 2 acetates, 1 calcium. Do we need parentheses? Yes, we do, because we have 2 of the polyatomic ions. So we're going to say Ca parentheses C2H3O2 close parentheses 2. Because the 2 went with the acetate and the 1 went with the calcium. Ammonium fluoride. So ammonium is NH4 with a plus sign. Fluoride is F with a minus. Notice it's +1 and -1. Don't be confused. This is not 4 plus. I see this a lot. People will write ammonium as NH4 plus. That is not correct. It is NH4 with a charge of plus. Big difference. All right. So it's 1 to 1. You simply crisscross it, and we write NH4F. Do we need parentheses? No. In fact, parentheses would make this wrong. There is only 1 ammonium here. You do not use parentheses. This would not be correct. That would be wrong. All right, this example here, iron 3 sulfite. So iron 3, transition metal, what does that 3 mean? It's the charge of the iron. So I'm going to say Fe3+. Sulfite is SO3 2-. Again, I'm going through these quickly because I've been going through these a lot. You'll eventually get to the point where you'll have several of these memorized. We crisscross the 3 and the 2. We will need parentheses because we're going to need 3 sulfites and 2 irons. So my formula is going to be Fe2 parentheses SO3 3. Because again, we have 3 sulfates and 2 irons. Zinc carbonate. Zinc is a type 1 metal. Even though it's in the transitions, it's always 2+. So it's zinc with a 2+. Carbonate is CO3 with a 2-. Notice 2 plus 2-, it's a 1-to-1 ratio. Do we use parentheses? No, no parentheses. It's just going to be ZnCO3. That's it, zinc carbonate. Ammonium sulfate. So ammonium is NH4 with a charge of plus. Sulfate is SO4 with a charge of 2-. So notice we're going to have 2 ammoniums, because the 2 carries, and 1 sulfate. And that makes sense. Sulfate is plus, ammonium is plus, sulfate is 2-. You're going to need 2 of these and 1 of these. Will we use parentheses? Yes, but only around the one that has more than 1. Notice we need 2 ammoniums. So you go parentheses, NH4, close parentheses 2, but we only have 1 sulfate. So you don't put parentheses around the sulfate. So it looks like that. Parentheses, NH4, close parentheses, 2, SO4. Last one, gold 2 phosphate. So gold is Au with a charge of 2+, because that's what that 2 means. Phosphate is PO4 3-. You crisscross the 2 and the 3. We will need parentheses here to go around my 2 phosphates. I'll rewrite it over here. It's going to be AU3 parentheses PO4 close parentheses 2. Okay, good luck with these type 1 and type 2 polyatomic ions.